In this section, we will discuss z-scores and outliers. A z-score is often called a standardized value. It's a measure of location that tells us how far a particular observation is away from the mean. Specifically, a z-score denotes the number of standard deviations a data value xi is away from the mean. Every value in a data set has a corresponding z-score. Some data sets have a lot of variation within the data set and others have less. Therefore, if we have a number in our data set that is unusually large or small, we have to take into account the amount of variation that exists within the data set. The z-score allows us to take this variation into consideration. A data value that is less than the sample mean will have a z-score that is less than 0 or negative. A data value that is greater than the sample mean will have a z-score value that is greater than 0 or positive. If a data value is exactly equal to the mean, its z-score value will be 0. The formula presented here on the slide is the formula that we will use to compute a z-score. The z-score for any data value xi is equal to xi, which is the data value that we want the corresponding z-score for, minus the mean divided by the standard deviation. If our z-score value is negative 3.5, this means that the data value is 3.5 standard deviations below the mean. If our z-score is positive 1.3, this means that our data value is 1.3 standard deviations above the mean. Let's explore this data set. Compute the z-score for the data value 216. Using the z-score formula here, the z-score for 216 is equal to 216 minus the mean divided by the standard deviation. For this data set, the mean value is 277.4 and the standard deviation is 48.84. Therefore, the z-score for the value 216 is equal to 216 minus 277.4 divided by 48.84, which equals a z-score of negative 1.26. This z-score indicates that the value 216 is 1.26 standard deviations below the mean. Here's another example. We have a list of grades. We want to compute the z-score for the grade 48. The z-score formula is xi, which is the data value that we want the z-score for, minus the mean divided by the standard deviation. Our z-score value for 48 is therefore 48 minus the mean score of 80 divided by the standard deviation of 14.73. The z-score value is negative 2.17. This z-score value indicates that the number 48 is 2.17 standard deviations below the mean, which is 80. Outliers. Outliers are values that are unusually large or unusually small compared to the other values in the data set. In this course, we will define an outlier as a value that is more than 3 standard deviations above the mean or greater than positive 3, z-score is greater than positive 3, or more than 3 standard deviations below the mean, which means that its z-score is less than negative 3. Consider this example. We want to determine if 225 is an outlier. Clearly, this value appears to be unusually large when compared to its peers in this data set. The mean for this data set is 66.63 and the sample standard deviation is 64.07. The z-score for the value 225 is 225 minus the mean of 66.63 divided by the standard deviation, which is 64.07, giving us a z-score value of 2.47. Although 225 is much higher than all of our other data values, technically this is not a z-score. Recall, in order for 225 to be a z-score, its z-score value would have had to have exceeded 3. Consider the data set given on this slide. Determine whether 24 is an outlier. You should pause the video at this time in order to practice this problem. You should have computed the z-score for 24 and obtained a z-score value of 2.11. This means that although 24 is much higher than all of the other data values, technically it is not considered an outlier.